Okay, everyone, we are going to look at number 13 in section 5.5. See it pulled up on the screen here. You have a function a of x is the integral from 0 to x f of t dt, with y equal f of x being the graph right here. So the questions you see that we're going to do are multiple choice, and they have to do with something about the function capital A, this accumulation function. This is not the graph of capital A. This is the graph of little f of x. What's the relationship between capital A of x and little f of x? Well, the answer is by the fundamental theorem of calculus part 2, the derivative of capital A of x, right? The derivative with respect to x, rather, of this definite integral is indeed f of x, right? That's the whole point of the fundamental theorem of calculus part 2. And again, the reason is here to evaluate this definite integral, we would find the antiderivative of little f, maybe we call that capital F, evaluate at the upper limit and at the lower limit and subtract. So we would be looking at the derivative of capital F of x minus the derivative of a constant. So the derivative of capital F of x is little f of x, right? It's the antiderivative. And the derivative of the constant is 0. So we get that the derivative of capital A is f of x. So this is the derivative of the function. This graph right here is the derivative, okay? So let's see. Does A have a local maximum at P? Well, if you look at the graph of the function, there appears to be a local max for the function at P, but this is not the graph of A. That's the graph of F. It's asking about A, right? Does A have a local maximum? What are we looking for there? Well, A will have a local maximum at a critical point where the derivative is 0 or undefined, and where the derivative changes sign what? From positive to negative. Derivative positive means we're increasing. Derivative negative means we're decreasing, right? So do we have a local maximum at P? No, because at P, the derivative, the value of the derivative is below the x-axis, so it's negative. It's not even a critical point. So the answer is no, because the function f does not transition from positive to negative at P. Does A have a local minimum? Well, local minimum, we need a critical point. What are the only two critical points for A? Answer R and S, right? That's where the derivative, little f is the derivative of A, is 0. So those are potential points for a local maximum or a local minimum. So local minimum, remember the sign has to change from negative to positive. So we're going from decreasing to increasing. Where does that occur? Well, negative to positive occurs at R, right? To the left of R, the derivative is negative. To the right, it's positive. So it's at R because the function transitions from negative to positive there. Where do we have a local maximum? Well, as I said, we have to have a critical point, and we have to change from positive to negative for a local maximum. That occurs at S. So S is where we are going to have a local maximum. Lastly, is A of x less than 0 for all x in the interval shown? Okay, well, let's take a look for all x in the interval shown. So the x values will, somewhere right around here, I guess a negative value of x, but some 0 all the way p, q, r, s, all the way up to here. Well, if for any value of x, notice we're going to accumulate area to evaluate capital A of x. And notice right here that A of x at any point will be the graph of at little f is below the x-axis, therefore it will accumulate negative area. So for any value, if we integrate up to like p, it would be the area, right, that's below the x-axis and above this curve, right, trapped in between the two. But it's going to be negative because it's below the x-axis. And that's true all the way up to r, right? Well, from r to s, yeah, you're above the x-axis. That's going to be positive area. But look at that area in comparison to the total negative area we've already accumulated. It's not going to make it positive. And then after s, we're back to being negative. And so the answer is yes, because the signed area from 0 to x is always positive. Okay, so I'm going to submit my answer. Well, I've messed up. Oh, I said always positive. Sorry. It was always negative. Good thing I checked that. So now I'll have to try again, and I will change my answer to yes because it's always negative. Submit my answer, and I solved it in 2 attempts. Okay. Bottom line, read the instructions carefully before you go on. Okay. Hope this is helpful. If not, please let me know.